Dr. Carol Mann here. Okay, the two sections, and this section is called Designing a Program. The other one gets more into depth in Python, and we'll get into that in the other presentation. But let's get started. So, designing a program. In some ways, programming is like painting. You start with a blank canvas and certain basic raw materials. You use a combination of science, art, and craft to determine what to do with them. Andrew Hunt. Very interesting. We just finished up multimedia and digital art, where we're using the canvas as a digital canvas. Okay, so now we're going into the programming aspect of the digital world. Just like we worked in HTML, now we want to think about what is the basis for programming. Like, what are the components? Okay, the basic components in any type of programming that you do. Okay, so you actually start with a blank canvas, and you need to know where you're headed. So you have a beginning, a middle, and ending. So that's called Software Development Life Cycle, or SDL. And as you can see from this graphic, that it's very important that you have a planning stage. Okay, you want to know certain aspects. You want to kind of shuffle them out. You want to know where you are going to, where you're headed. Okay, what is going to be your end product? What do you want the customer to have in hand? So you're planning. Then you're going to defining exactly what it is. Okay, it's like a problem, defining it. Then you have a designing stage. So it's very important you have those two pieces in at the beginning. Then you have a designing, then you get into the actual designing of it. Okay, again, you have a beginning, a middle, and ending. Then you get to build it. Okay, and that's where all the programming comes into play. And then you test your program. You might have to go back and iterate again because you're not sure if that is the results you want, or maybe it isn't the results. And then you have to go back and try again and go back and look at all the stages. Okay, and then you test again. Then you deploy it. Okay, because it's right now. You think we got it. And then maintain it. So then you have to maintain the program. Just like you get software patches for software, that means it's maintaining. Okay, you're keeping it up to date. So this is a different way of looking at it too, from a marketing perspective, a company perspective. From at the very beginning, you have market research and business analysis. Then you create a plan and a budget for implementing the software. Okay, so you're still doing the basic, okay, I have the beginning, I'm getting my plan into play. Okay, I have, and probably what I want the customer's end result will be. So then you're testing, then you're programming the actual software. Again, there is that, putting all the hyperlinks in, the text, whatever, however you're doing that program. Then you're testing it. Okay, from testing it, you might not be what you want it to be. Maybe it's not the end product. Maybe it's not the software piece that you want the customer to be using. So then you have to go back again, think about, your plan, and start programming it over again. Think about the market, think about your business analysis. Then once you've done it again and testing it in, you release it software to the public, and then you have to maintain it with bugs, patches, like I said, once your software is actually out there. So there's actually an output. And then if there is problems or things that need to be determined or need to fix things, that is where you send patches out. Then you keep going around. Okay, now is the bug or the fix part of the actual business analysis or business plan? If not, then you should go all the way around again. So it's a circle. It's a life circle. Okay, just like everything else is, goes in the circle, and everything is connected. Same thing with software. So importantly, again, you're determining the steps that make that must be taken to perform the task, right? There's a beginning, again, a middle, and an ending. What is the final product? What is the final task? You break down the required steps, and you break down the task into required steps. Okay, you iterate, you keep going back and forth to make sure that you got the steps in the correct order. Then you create the algorithm. The algorithm is the actual programming itself. So you have to really understand what that task is, what the problem you want to solve is. You really have to get down nitty and gritty and think about it. Okay, you want to inquire. You want to go to a market, a test market. Okay, you want them collaborating with you, communication. You're asking questions before you actually get into the actual programming. So it's really important to understand beforehand the design, okay, before you get into writing the program. So it's design, write code, correct syntax errors, test, and correct logic errors. Plain and simple in a programming aspect. All right, so the algorithm is the last piece. So it says it's a set of well-defined logical steps that must be taken to perform the task. This is a wonderful, wonderful video. Please watch it. I strongly suggest, please watch it. It is really great. This algorithm goes for everything. Whatever you're either software programming, whatever project you're working on, it's just really very, very informative. Okay, so then there's something called pseudocode, which is a fake code. And that is informal language that really has no syntax rules, is not meant to be compiled or executed, is used to create just a model program. So you focus on the program's design, not the error, and it's translated directly into actual code in the programming language. All right, so that is something that is also part of the actual cycle. This video does a great way of introducing it to you and putting it in vocabulary that is easily understandable. Okay. So here is an example of a flowchart, a program flowchart for calculating pay. So this one is a program, written program, and then as you can see, it has a beginning, a middle, and an ending. The diagrams, the shapes represent certain items. So for instance, the ovals are terminal signals. The parallelograms are your input, okay, input, output. And then the rectangles are your processing symbols. And the symbols are connected by arrows representing the program. So these are the steps. Okay, this is the outcome. Okay, input is what inputted in. This is inputted in. Then you have a calculation, and this is your output. And then you have an ending. It's like Van Neumann's architecture, if you remember way back when. Okay, your CP unit is right in here with all the arithmetic or algorithms in here. And then you have your answer, and it's the end. So beginning, all this stuff here is in the middle, leading to the end, your final result of what you want your program to reflect. All right, that's it for this one. So please email me with any questions. Thanks again for watching and being a great audience. I really, really do appreciate it. And happy programming.